So let me introduce Nancy Hayden from Sandia National Labs. She's been involved with peace engineering since 2018 with Pablo when he was at Sandia. We co-organized the first Global Peace Engineering Conference, and they've been very active in peace engineering. And Sandia, one of the strategic thrusts is about peace engineering. Nancy, can you hear us?
I can. Can you hear me?
Yes. Yes.
Oh, okay, great. I apologize for the difficulty in getting on. It's just great to see all of you. It's great to see you, Joe. It's been too long. So, and Ramiro, we've missed a few of our meetings of late, but it's great to be here at this workshop. And I'm sorry I can't be there in person, but it's a really privilege and pleasure to be talking about peace engineering. And when I first met Ramiro and we talked about our mutual interests at the conference back in 2017, 2018. I had just finished a PhD in a field that I thought I was pioneering. And then I found out, oh no, it has a name, peace engineering. And what I was looking at in my very late in life PhD that I was working on was involving complexity science and modeling complex systems to look at how some of the things that I just heard come up interact with each other in conflict settings. So what I was particularly looking at is the side of where you have conflicts and you're trying to reduce the violence, you're trying to provide a secure environment in order for the peace processes to happen. And so that in the conflict world, that's often called, the security side of intervening in conflict, and then there's the humanitarian and development side of intervening in conflict, and those worlds don't talk to each other. They don't talk to each other in the field. They don't acknowledge how they are both interacting in a complex system. And I was so excited to hear Ramiro's vision and participate in the development of this field where you look at both at the same time, just as which is stated, no technology and no intervention. Technology is only one part of an intervention. There's policies, there's science. None of it is neutral in practice, it turns out, even when we go into it with the intention. And peace engineering gives you a framework to evaluate all the different ways that those, the science, the technology that engineers develop, and the policies, environment in which that shapes how they're deployed, how you can assess, will you achieve the outcome that you want to have? And Sandia just embraced this wholeheartedly. At the time we had just entered a new management, and Steve Younger was a director at the time. And I brought the whole idea. Sandia explored how peace engineering fits with what we do. And basically Steve Younger, our director at the time, said, peace engineering is the goal of what we do. We are developing technologies to bring about global peace. And whether you believe in that in terms of the politics of nuclear deterrence, which is what Sandia is about, we're very heavy on the security side of that equation, of the full scope of what creates peace. We are very involved in the development and the aid side as well. And what we really embrace so strongly is the framework that peace engineering provides, and the new disciplines, like Ramiro just said, of what do we need to do and explore that's new as the world is changing around us, to understand the dynamics that are always there, always in tension in society and communities, for both security and development, and how those come about to resolve conflict. And I don't know if you've already said this, peace in our definition is not the absence of conflict. It's what we are striving towards is that as conflict emerges as part of the human condition, that we find ways to work through it without resorting to violence, whether that be physical violence or economic violence or other kinds of injustices. So we really embraced this. We looked hard within Sandia, and we made the decision that this, given our mission and our role as a primary federal research laboratory for the Department of Energy and for the National Nuclear Security Administration, this probably was never going to be a brand new thrust at Sandia, but that we can frame so much of what we're already doing within the peace engineering context and use that as a compelling force to bring many aspects of what we do together in new and powerful ways. And as we explored that, we came up with a theme of 5 particular areas that we introduced last year and we continue to work on this year. And I'm going to share my screen to talk about some of those. It's not everything that is relevant at Sandia that let's see, select window or screen. Okay. So we came up with, we looked across what we do and we came up with 5 areas so one of these is material sustainability. Sandia does a lot of work in engineering materials. And so we consciously and intentionally brought peace engineering to the researchers in our materials area for sustainability and brought about some specific exemplars where we're reducing some of the exacerbators of conflict through materials. Materials are such a basic, fundamental, everyday research area, and yet how we research materials and the materials we generate, the way in which they're used in our engineered systems can really generate a lot of positives for society through the circular economy and reduced reliance on materials that are environmentally unfriendly, as well as we develop those that can advance renewable and abundant resources and leading to zero human footprint. And when there is all else being equal in terms of cost and time to develop and the supply chains that are generated, including things like, what is the carbon emissions when you have a particular supply chain for a particular material. So really thinking through all of these and using complex predictive computation for the entire system to inform the materials research work that we do. Another is, and this one I'll probably spend a little bit more time than the others talking about, is in climate security. And we have a large program in climate security. And as all of you know, climate security is a global commons problem. And there at Sandia, we have a program with 4 themes in it. One is awareness and prediction. So we do a lot of sensor as engineers. All of you do this, right? We do a lot of sensor and monitoring technology development. How can we improve those and then predict what's happening? Improve those to monitor what's happening in the environment, be able to understand what's happening in local areas and tie that to the large climate picture at large and predict what is happening with climate change. There's so many unknowns. And then our programs for adaptation to what we expect the climate to do, programs for mitigation as well as intervention. And when I last spoke at a workshop last year, we were able to talk about some work that we'd done the previous 2 years looking at very large Arctic systems and how peace engineering framework allows you to look at the different interests, the opening of the Arctic and the security interests, as we know that there'll be new waterways and how we're designing new systems for both exploiting what is available in those new waterways, but also monitoring what's happening there. And to do that in cooperation with the communities, to really understand how the indigenous communities in particular see these new advances as opportunities and or threats, and to incorporate that into the picture that is developed on different program levels and being able as engineers to really inform both the communities, the policymakers, and the engineering developers of the systems that might be going into the Arctic. And so doing all of that through this peace engineering lens, whether you understand the complexity, both the negative and positive consequences of the technologies that are introduced and how they're introduced. 2 examples since then I want to mention, and I'll be happy to answer questions on. One is we worked with a group of students at Brandeis University and the DOE chair of at the time, he's no longer the chair, but he was the DOE chair of the Office of Arctic Energy Programs, looking at the implementation of small modular nuclear reactors in different communities up there as the Arctic is opening up and warming. There's a lot of issues with the traditional fuel systems that are very fossil fuel based, require a lot of propane and natural gas transportation across frozen roads. None of that's going to be viable. And how we might deploy small modular nuclear reactors. And we used a group of engineering students that are studying system dynamics to develop community-based group models where you can, we're just, as I was coming on, listening to Joe talk about putting things in front of the community, being able to visualize it. This is a large model. This is not one of these for the nuclear engineering, but it is a system dynamic model, not just an influence model. You can actually code in some of the different rates of sentiment change, of economic change, of benefits, and when they come online, and the potential for accidents, et cetera, and do that with input from the communities, and then work through the models with the communities, with the policymakers. George Rowe used this with the Arctic Nuclear Energy Council. And so these are the kinds of things that you can get engaged with as peace engineers, trying to bring the different perspectives and principles to bear on designing technologies and systems for these complex problems as we go into the future. Another one involves forecasting in the future what kind of impacts you might have in intervening in climate. There are pluses and minuses to the ideas that are being explored right now for geoengineering through especially modification of solar incidents on different parts of the planet. Some of you know this is cloud seeding. Some of it can be marine cloud brightening. There are some areas of the world where the forecasted climate changes are so severe that there's been, even in some war games that have been played out in Washington, D.C., the assertion of one country potentially using climate intervention to solve, for example, a drought, having negative consequences in a neighboring country, leading to the really large-scale conflict erupting. So one of the things that we've been looking at is how can we take models of really global commons problems with technical solutions that have potentially unknown consequences. How have we solved and looked at those in the past? And we've looked at things like some analogies that I was involved in earlier in my career, where we were looking at licensing nuclear waste repositories, for example. This is a large engineering problem, global consequences, lots of policy options, lots of stakeholder input, some regulations for what your targets were and predictions of whether or not you could meet them with different kind of engineered solutions. What could we learn about that process for engaging in a dialogue around the desire for intervening in climate changes in different parts of the world where there might be really severe humanitarian benefit as well as unknown consequences and concerns? And how do you do that in a way that involves the communities, stakeholders, engineers, scientists, and policymakers? Some other examples that we are looking at right now are some of the work that was done on the Chemical Weapons Biological Convention, for example. Others had to do with the promulgation of environmental standards for CF6 emissions. So those are some of the areas that we're looking to past, sorry, didn't mean to do that, successes in coming up with framework for tackling these problems in a really large way that involves significant consequences and stakeholders. Another area, and I want somebody to give me the hook if I'm taking too long. I'm trying to move on to the next one. We've got some of our energy programs at Sandia, heavily involved in the Department of Energy's and the federal systems, energy equity and environmental justice initiatives. Some of those things involve where our engineers are involved in developing social burden metrics and their adoption in energy infrastructure planning, for example. So this work involves the research and development that's typical of engineers, but also taking the solutions to the field, working with the community in the field for education and outreach, and working with government policies. So I think you're seeing a consistent theme of this coordination between policy and technology and community. Another one that we've really worked hard at understanding is how the peace engineering framework can help us go across scales. So how we go from local issues around conflict to advancing the global security interests, where we cycle through this whole circle of recovering from violence at the community level scale to peace building that deters violence and develops regional type solutions that can then be engaged as in the future for crisis response and stabilization. I think we've worked with Drexel University on some of those. And then finally, someone already mentioned complex systems. So we do a lot of work at Sandia on complex systems modeling. You're going to hear from one of my colleagues, I think later in this workshop, on some social dynamics interacting with psychology of humans, and then being able to insert into that some of the ethical issues and the economic issues, the human issues, as well as the technology issues. And I don't know if Ramiro, if you've got it on the plans to talk about the periodic table of peace engineering, but whatever metrics you use, being able to implement these dynamics in complex social systems modeling with the technical systems, the ethical and the policy will be a key for being able to forecast, as was already mentioned, plan for unintended consequences, and engage these communities that we want to interact with and deploy our solutions to for the peace engineering purposes. So this is a snapshot. I'm going to quit sharing my screen of many of the areas that Sandia is involved in. We love having students come and work with these. We love partnering with UNM on them. And just kind of as a parting comment, I want to echo the last question I heard was asking about dual use technologies was the question. I say policy can be as equally dual use, or economics. Everything is born dual use. I've done a lot of work in the space security environment. And in space, we worry about the one treaty that we have is prohibiting the deployment of weapons of mass destruction in space. But in actuality, a hammer or a screwdriver can be a weapon in space because of the damage that it can cause. So we have to be cognizant of the consequences of everything we develop, not just the intended design of it. And with that, I'll stop. And Ramiro, if I have time to take questions, I'll be happy to do so.
Thank you, Nancy. You stopped at the right slide, because after the break, Bruce will be talking about the periodic table. Questions for Nancy? Veronica?
Thank you for your presentation. One of the concepts that I just want to bring up is the overlap with the core functions of public health, and that's assessment, policy development, and assurance. So my point to one of your slides that you have listed the principles and end up at intervention, I would like to suggest that also an evaluation, a health impact evaluation is being adapted, because I think we always ask the question, what's the economic impact? But we forget to ask what's the human impact, and what's the impact that any of those proposals have on the health of the community. So that was my point. Thank you.
That's a great point. I think we so often, as engineers, forget to go beyond just the technical evaluation and include the entire system evaluation, which is the health and well-being of the communities. And oftentimes that might not be the policy objective. And so if it's not an explicit policy objective, to make it one and evaluate against that. So really appreciate that.
Thank you. One more question, Javier.
Hello, Nancy. Xavier Barraza with Los Jardines Institute. I was curious, are you all doing any adaptive, complex adaptive system modeling around the health equity and impacts regulation being proposed here in the city of Albuquerque with all that computing power?
You know, I do not know. I think that's an excellent question. We just had Mayor Tim Keller come out and give us a talk last week, Thursday, I think it was, about the ways in which Sandia is collaborating with the city. The area I do know that we're doing a lot of work in is with analysis of statistics and modeling for violence intervention. But if you could write that question down in the Zoom, I would love to follow up. I think that would be a great thing to know about, because I don't know the answer to that. We do a lot of complex adaptive system modeling at Sandia. And if we're not, maybe that's an area that we could get engaged in.
Sweet. And just as a follow-up with that complex adaptive system modeling that Sandia is doing, where would maybe the public or some of the collaborators here find the documents and reports on some of the modeling that's been done on the health or economic impacts of the communities who host the labs? Is there any complex adaptive system models explaining those impacts for hosting the laboratories?
You know, I don't know if they use I know that there are models of, you know, the impact of the labs on the communities. Some of those are looking at the economic impacts, which you'd imagine. They're very, you know, they're very pro labs. Here's all the ways in which the labs bring money to the communities. I suspect that you have other questions on your mind that you'd like to see included in those. And if you could be specific about what those are, I could search for those models. There are a lot of studies, like I said, of the impact of the labs on the communities. Whether or not they actually use some of our complex adaptive systems modeling, I would have to research to find that out.
Thank you so much, Nancy.
Thank you, Nancy.